When you're building a high scale, mega scale, super big social network, you tend to find yourself needing to do some interesting tricks, including database sharding. And when you're doing something as grand as building a social network like Twitter or BlueSky, you really need to take everything into account and all the possibilities of creating the best possible experience. Excellent latency, resiliency, uptime, all of those things need to happen. Distributed resilient compute is a challenge. One neat pattern that we're going to check out here in a bit is what happened recently with the reference implementation for the AT protocol. They did something pretty neat. Often what you do at these types of scales is you need to do something called database sharding. And under this case, they went to the extreme. Every user has their own database. This is pretty powerful because it lets you do a lot of things from a data resiliency, also from a data management perspective. Because if you want to be forgotten, it's really easy to delete that one database file and it's gone. The drawback though is if you want to do aggregate analytics, you have to cross-examine every single database file, which is a lot of database files in this case. So there's always going to be this aggregation that needs to happen before you can even do any sort of analysis. So zooming in here, let's take a look at what they actually did. They've merged this to create a single-tenant SQLite data store. BlueSky, the AT protocol, has interesting upgrade. Check it out. They've done something that you need to do when you're expecting a massive scale. Database sharding. Every user gets their own database. That's like the most extreme database sharding that you can have. I guess you could go a step further and you wouldn't do this, but you could have only one row per database. That'd be silly. I mean, at that point, there's not really a database. Technically, it is still. Here's what they did. They allowed us to refactor the PDS. BlueSky PDS is the personal data server, which is a huge aspect to the AT protocol, authenticated transfer protocol, AT proto. It's for large-scale distributed social. And when you have such a large scale that you're planning to distribute, lots of servers, lots of computers, you need built-in redundancy and reliability. The refactor for the PDS is a single-tenant SQLite data store, and each user has their own SQLite file. They did it like this. Here's the directory structure. They take the first two characters of a SHA-256 hash of the, looks like the user ID, person ID, it's some sort of ID. They use that as a directory so that way your directories don't get too big, because directories can get pretty big pretty quick. And then they store the actual database ID here into that folder. This isn't a small change. I mean, you would think it would be pretty straightforward, but there's a lot of commits. Look at all the, so many, a massive amount of work went into this one. Also, was not expecting this. It looks like it's all TypeScript. Here's the code that we're talking about, and it's all, looks like, this is very interesting. It's all TypeScript. I was kind of expecting it to be something more like a Rust or a compiled language of some sort, but it looks like it's TypeScript. So here's where we get the disk directory for the database itself. The SQLite store returns the directory and the database location. They go a step further by using SQLite in more places than just for the user data store. If you're building a social network, especially like BlueSky is with the AT protocol, you're going to need to think big. Expect large numbers, especially today when there's so many users online. And a good way to think big is to use systems that are going to be efficient and nimble that supports this kind of traffic. SQLite is the way to go. The most widely database, that database is so widely used, SQLite. They like it so much that they're using it for everything. Operational service data with the account info, invite codes, refresh tokens, sequencer tracking for table. He said, what is this? I don't know what that, what? All right, this part of the blockchain likely holding the tracking information for changes over time. And of course, the cache for the user data. Ooh, and in order to ensure concurrency, it looks like they add data access in wall mode for allowing concurrent reads and streaming replication. And wall mode is the write-ahead logging. Ah, okay. And we like this write-ahead logging because it's a lot faster. More concurrency, more readers, fewer blocks, and allows writes. Writes do not block reads. Ooh, okay, we like that. Okay, this is fantastic for big scale. When you go in big scale, this is the scenario. You want this. Excellent. There's some great advantages here, but then when you're looking at the disadvantages, it kind of scrolls down a little bit. I see. Okay, BSF. It requires this shared memory primitives. This is a downside here. You cannot use network mounted file systems are a challenge, so you'll need a local disk native to the device. Transactions are interesting in this case and require a little extra effort. I wouldn't necessarily count this as a downside, but there's these side files, the WAL file and an SHM file, which are 2 extra files per database that have to be stored on disk. That seems fine. Okay. This is a neat pattern overall. when you're using databases, any kind of database, when you're sharding the data, using a pattern like this is very common. And it's necessary for high scale systems where you have a lot of users and are expecting a lot of traffic. One last bit before we go, we see that they're using an LRU cache here for 30K open file handles. Since we have a database per user and we're also in wall mode, so there's 2 extra files associated with each database, you're only going to want to have a limited number of open file handles because the OS only gives you so many in the first place. So this is an added overhead of management and maintenance that you need to take into consideration. Building high scale systems, all sorts of fun things come into play.